So the next is future value of an annuity due. Just based on the same information as a prior example, the only difference is now the cash flows are located at 0, 1, 2, while the future 3, we're going to calculate the future value of these cash flows. Comparing to this slide, we find for annuity due, the cash flow just one period earlier than the same ordinary annuity. Following the same methods, we can calculate the future value of each cash flow. This cash flow starts from 0, accumulate 3 periods, this accumulate 2 periods, and this one accumulate 1 period. We calculate the future value of each cash flow, and the sum of them is the future value of this annuity, specifically this annuity due. The first payment accumulates 3 periods, so that's future value factor for this. 2 periods, 1 period. Then we find the future value of each cash flow, and the sum of them is the future value of this annuity due. Comparing to the value of last example, 33,100. So the future value of an annuity due is greater than the ordinary annuity. Under the assumption both have same amount of payments, same interest rate, and same number of periods. Instead of using the single sum methods, we can also use the future value factor of annuity due. We are not given the table in this PowerPoint, but we are given the factor. You just use this factor, multiply the annual payments. This will be the result consistent with the methods we just used. These tables are all available on the Connect. We work on your quiz, homework, and test. Even I don't have the table for the future value of an annuity due, actually, because their relation, I can use the results from the ordinary annuity. For 3 periods, 10%, the factor was 3.31. And based on the relation between annuity due and ordinary annuity, I know the future value factor must be the ordinary annuity future value factor multiply 1 plus interest 10%. This just equals 3.641. This is as what I introduced in the prior slides. We can use this relation even we don't have the table for AD, annuity due. If we have ordinary annuity, we just multiply each factor by 1 plus I. We can get the table for annuity due. So here is an example. Let's first analyze this question. This corporation wants to accumulate $8 million for planned expansion. So this also indicates this is a future value. The time when it was needed will be on January 1st, 2029, or December 31st, 2028. And the company plans to make 5 equal deposits. So it also implies this is an annuity. But what type of annuity depends on the follow-up information. We're given interest rate compounded annually. So we have I 7%. Because compounded annually, 5 equal payments, the N also is 5. What we need is what type of annuity it is. The first deposit was made on January 1st, 2024. So that means the company make the first payment at the beginning of the first year. 2025, the second. 26, the third. 27, the fourth. 28, last. Okay, so also based on this information, we know this is an annuity due. Now we have all the information. Based on the formula of future value of annuity due, we just need the payments multiply future value factor of annuity due, which is determined by interest rate and the number of periods. We are asking for the amount of deposit each year. In other words, we are solving these payments. What we need is the future value. Future value is 8 million. And the next is the future value factor of annuity due. We are given all this information, but we only need one. Actually, this one. The future value of annuity due for the payment $1 at 7% 5 periods. Then we just use future value divided by the future value factor of this annuity due. The payment is $1,300,813. The answer is A. Quarterly deposit $200 for 5 years into a saving account. The first deposit was made immediately. That means at the beginning. Interest rate 8%, compounded quarterly. How much he will save or accumulate at the end of 5 years. So 5 years, each year 4 deposits. So that means N is 5 years multiplied 4, 20. The annual interest 8%. So interest per period is 8% divided by 4 because interest was compounded quarterly, so 2% each period. And the payment each quarter, $200. Since the first payment was made immediately, it also implies this is an annuity due. Based on the formula, we just use $200 multiply the future value factor of annuity due. N is 20, I 2%. So the information we need actually is this one. The future value of an annuity due of payment equals to $1, 2%, 20 periods. Then we just get the results, $4,957. Based on this assumption, he can accumulate up to $4,957 after 5 years. Again, quarterly deposit $200 for 5 years. The payment was made at the end of each quarter. Interest is same as the last example, 8% compounded quarterly. Same question, how much he will accumulate at the end of 5th year? Okay, so the only difference is the description of the timing of the payments. The only difference, the future value factor of this annuity is the ordinary annuity. So we just use this one. Multiply the periodic payments. We get $4,859, which is less than the last example. $4,957. Okay, the reason is because the payment was made one period later, so it accumulates less time value of money than the annuity due.